Hello everyone. I hope you are all doing great. My name is Alexandru Botezatu and I'm a fresh graduate from University of Aberdeen, where I studied a master degree in petroleum engineering. On behalf of PioPetro, I would like to welcome you all to the second session of Effective Python Programming for Exploration and Production, which is held by our special guest speaker, engineer Yohanes Nuwara. Yohanes Nuwara is now working as a distributed acoustic sensing geophysicist in the Wright Institute in Kyoto, Japan. He also holds a bachelor in geophysics. He had achieved outstanding achievements in many places. One of them was minus CO2 challenge by Equinor and EAGE in 2018. He had several high-ranked publications. One of them is about integration of rock physics, time-lapse seismic modeling, and geomechanics for CO2 storage, in which he will present in the 82 EAG annual conference this October in Amsterdam, Netherlands. He had been working on open source Python programs for geoscience and petroleum engineers since 2020 and had been teaching to more than 1,000 SPE students and professionals worldwide. In his free time, he loves writing blogs in towards data science, medium publication involving his Python for geoengineers community in Telegram, reading biography books, and doing sports. Now, I am sure you are all excited about today's session. And as a side note, if you have any questions related to this presentation, please feel free to write it down in the Q&A section. Now, without any further ado, let's welcome together Yohanes Nuwara. Mr. Yohanes, the mic is yours.
Okay, thank you, Alexandru, for your introduction. It's a really great day today here. So welcome to our second session in effective Python programming. If you still remember last Saturday, what we are covering, basically we are covering about the basics of Python, how to operate NumPy and basic libraries on how to make a data frame. I hope you all remember that, because that's the basics that you have to know before you are going to further applications of Python. And so today we are going to directly into the applications of how you can use Python for your whatever your study, your research, or your career. If you are working in a company or you are working in a research institute, you can use this resource that will be helpful for your entire workflows. So today we are talking about production data analysis. I think this is a quite interesting and sexy topic, because data analysis and data science is the most popular term nowadays. And in order to understand how we should do with production data analysis, yesterday we covered about data frame. So today we are going to use data frame again to analyze production data. Here, if you see in my screen, this is one of the fields in the North Sea. And what is so special about this field is that in 2019, I suppose, the company Equinor, it's a Norwegian oil company, discloses their data for public. So you can access this data for your study, your research, or your thesis in the website. So this is the full field. It is located quite 500 kilometers from the Norwegian continental shelf, or the NKCS, in the North Sea. Although there are lots of fields there, for example, Norn field or Snore, Sleipner, they are all those big fields in the North Sea. And if you go to this link, I'm sure you see this link. This is the link where you can download the data from the full field. And this full field data set or database consists of lots of data, not only production data, but geoscience data and drilling data, other engineering aspects in the field. And one of the data that we will practice today is production data. It consists of this information, okay? So basically, you can see this data. I have already prepared it for you. You can go here. If you type bit.ly, this link is biopetro dash data one. Okay. If you click this link, you will get all of this data. Okay. So with this data, we will analyze using Python. Okay. So using the resource or the tool that we have done last Saturday, we opened directly our Google Colab. Okay. So that's quite easy to access Google Colab, because as we know, it's free and it's online. You don't have to download the IDE. Okay, so maybe that's the answer of the yesterday's quiz. If you work on that, and in this Google Colab, you can make a new notebook just as usual. So basically, I have already prepared all of these things, and today we will code from scratch. But you can make a new notebook and make your own title. But here is our template. Okay, so first of all, this is our title today: production data analysis. Okay, and some libraries that we have to import today are the libraries that we have discussed last Saturday, which is NumPy, Pandas, and Matplotlib. Okay, so these three libraries are what I say appears every time we use Python. Almost every time we use Python, we use these three libraries for our daily activities. And also, other two new libraries here that we haven't already discussed last Saturday is the Seabourn and Missing No. Okay, Seabourn is a library that is used to visualize the data. Okay, if you know in statistics, perhaps you get statistics in your college. For example, you want to create a histogram or box plot or scatter plot, you use this Seabourn library. Actually, Matplotlib can do these things, but Seabourn makes it more flexible. Another library is called the Missing No. This library is used to inspect if there are any missing values in our data. So the name tells it all, the missing no. So it will inspect if there are some missing values in our data. Okay, because it's quite often when we get a data from the field, we lost some parts of the data. Okay, and if you use this missing no library, you can inspect or identify which part of your data is missing. Okay, so after all, we just import all of these libraries just as we did before. Okay, so the first three libraries is for NumPy, Pandas, and Matplotlib. Okay, .pyplot as PLT. And the next two libraries are the Seaborn and Missing No. Okay, so we import the Seaborn, and our abbreviation for Seaborn is quite often we name it as S and S. Okay, and for Missing No, we can abbreviate it as MS No. Okay, so if you still remember our discussion last Saturday, every time you want to import some functions from this library, you have to type first the library. Okay, for example, you want to make a histogram. Okay, so the first thing you have to do is you type the library first, the Seaborn, and then followed by the function that you want to run, which is the histogram. Okay, and also you can sorry, it's not histogram but hist. It's only hist. Okay, You can also see the documentation, what inputs are required to run this function by typing help sns.hist. Sorry, so this will be a histogram, I think. SNS, PLT, oh, sorry. Not histogram, but pair plot, okay, or scatter plot. So this function we will use later on. So in this help, you will find all of the required inputs to run this function, okay? Okay, so now we are going to load our data, okay? This is our data. So in a form of link, you can go directly to this link. And if you type this file path, it tells you that where you will access the data because we will access the data directly to the website. So we use the link, okay, instead of the directory in our files, because here we run all the programs the website without any access to our computer. Okay, so that distinguished the cloud computing from the local computing. Okay, here we do a cloud computing, we access the data directly to the website. Okay, and how to load the data? We use pandas. Okay, so because we will use a data frame, so again we make a new variable df equals. We use a function from pandas that is called read_csv. So you have to type first pd, which is pandas, and we have read csv. Okay, that's quite simple. And the first input that you have to run in this function first is the file path. So this is the file path. Okay, so that's it. And if you want to read the data, okay, you just print the data, okay, the df. So it will print all of the data exactly when we go to the link before. So this is the CSV file or comma separated file, okay, and it quite looks like in Excel. So that's why I prefer doing in Python because it looks like in Excel, okay? And this is our data. And if we want to look at the first 10 rows of the data, okay, you can see this one's head 10. So this will print all of the 10 first rows of the data, okay? And if we want to inspect the last 10 rows, we use tail. I think we have already discussed last Saturday here, okay? So this is our data. What we see here, we have to understand what the data is before we do a lot of things with our data, okay? So first of all, let me discuss with you what contains a data, okay? First of all, you have to know what is called as feature. Feature is the column in our data. This is quite important because in your quiz, okay, this will be repeatedly stated. Okay, so if you understand this, don't worry, you can do the quiz. So what is feature? Feature is the column of our data. And where is the column? Here is our column here, date production, NPD wellbore name, on stream, okay? So these are the columns of our data, okay? Or the features of our data. The second thing you have to know is what is called as observation. The observation is the row of our data, okay? So if we know feature as the column of the data, now observation is the row of our data. If you see here, these are the rows, okay? And there are about 15,000 rows here, okay? So these are the features and these are the rows, okay? And the next thing we can do with this data frame, if you see here in the date production column or date production feature, you will see this format from Excel. So if we want to operate it in Python, we have to convert the format from Excel to Pandas. The way we can convert the format is use what is called as the function name to_datetime. Okay, so if you see the documentation, help this one, PD to datetime, this is the function to convert this type of format into Pandas format. Okay, what is exactly the Pandas format for the date? Okay, so here you can see this is 14 September and 16. In Python, the format should be like this ones. For example, today is 1903. Okay, so this means 3rd of March in 1997. So this is the format in Python. Okay, this is format in Python. Okay, but you have here a different format. So you have to change this format into the format in Python. So, and the next thing you have to do is you have to convert the format. Okay, so we use the to_datetime function, and here the df equals PD to datetime. The following input is the date production. So if we still remember our previous discussion, if we want to extract the information in certain column, for example here, the date production, so you can use this df bracket date production. Okay. And in this function, we will pass the exactly similar. Okay, so this is our data that we want to convert here in this column. And then it is followed by the format. Okay, and then in this format, you have to see how is the date written in the original data. So first you see the 07, this is the date. Okay, so in Python, it is recognized as this D. Okay, D is 03. Okay, 03, 09, 10, 11, and then it is followed by this dash. So dash B means that all the months here. Okay, April, so only the abbreviation of the month. September as Sep. Okay, and then followed by the year, because the year is only 2 digits, so we used Y. Okay, actually you don't have to worry about if you have different data, what should I write here? Okay, because if you browse in the internet about Pandas datetime format, you will see some list of certain these conventions, and you can convert all kinds of format into Pandas. Okay, but right now I just show you one of the formats, and you can explore further after you follow this training. Okay, and if you print the data frame after we convert into the date production, okay, so we forget to add this date production. And then if we print again our data, it will be changed now. So these are the Python format. It's already changed. If maybe we forget to convert this. If you want to plot the data later, you cannot do that, okay? Because it is not recognized in Python. So you have to convert this. So you have to remember this. If you have a data, you have to look at the format and then you convert it into Python format, okay? And it's all set here right now. We already talked about features and columns. And if you want to find what features are inside my data or what columns are inside my data, instead of looking here, all of these columns, you can list down all of them, all of the columns, because this is maybe some data has lots of columns, lots of features. Maybe it can be 100 to 200 features. That's really common in production data or in or any other data in petroleum engineering. Okay, so how to print all of the column names? We print this df dot columns. Okay, and then you will get all of the features in our data. So these are our column names. Okay, and then if you see in this data, you will see that this data is not only contain one well. Okay, there are lots of well here in our data. Okay, so maybe you want to print here the data here. We back to our data. Okay, this is the name of the wells. Okay, and if you go down here, you will see a different. Okay, so this is different wells. These are the different wells. So this data contains different wells. Okay, and how do we know what wells are in our data? So we can print all the well names. Okay, how do we print the well names? We use this df dot unique, and it will print us all of the well names in our data. Okay. Sorry. So pay attention here. The well names are inside this column. Okay. So if you want to see, again, you want to see the column. So this one is the well NPD well bore name. It will print a column. Okay. So this is the information in our wellbore name, and if we want to print all of the well names here, because we can see the duplicates only, we can also print all of the well names. So we print this NPD wellbore, okay, wellbore name, unique. Okay, and these are the well names, the individual well names. Here you cannot see the individual ones, okay? And it's quite complicated for you to trace down all the individual names, so you can do this automatically with these lines of code here, okay? And then our task now is we want to analyze only one for one well. Okay, we want to analyze this well. Okay, so remember last week we already discussed how to mask a data, how to create a mask. We run an example of list of names and who was working for which company and and who are working for what, or the date of birth, and we create a mask to select who are working for a certain company. So maybe you can go to our previous tutorial and see what we have done before. And now we did exactly the same as we did yesterday. Okay, so first we search in this data which one is from this well name. This we will use this well. Okay, and first of all, we make a mask. Okay, so it's really similar to what we did before. So we create a mask. We place a data frame here, and inside this bracket, we type. Okay, I hope you understand this. You want to find this well, okay, in this column. You want to find this. You want to find well F14. Okay, so you pass this column and search for well 14. This two, okay. So this we want to search the data that is from this well, okay? Because there are lots of wells in the full field, we want to select which data is our preference, okay? And then after we create this mask, for our data. Okay.
Johannes, if you don't
Okay,
mind, Johannes, if you don't mind, can you repeat the last minute because the voice was not clear?
Yeah. I think so, because I also find some internet unstable here. Okay, so basically what we are talking right now is we want to select the data that is coming from our certain well. For example, we want to select well F14 from this data. So we use this code to make a new data frame that only contains well F14. Okay, so if we use this code and then we print the data, okay, sorry. So this is not the right code. Okay, so this is double. Oh, no. Okay, so without this bracket. Okay, so if we print this data, okay, we run this function, you will find the data that contains only this well without any other wells here. Okay, so we have already get our data for F14. Okay, the next thing we want to do is right now we go straight to the data analysis. Okay, the first step in data analysis, we want to find the average, the minimum value, maximum value of the data. Okay. Okay, so maybe I'll show you directly how to do that. We use df because we have already created a new data for this well. So we use data .describe. Okay. Okay, here, how to interpret this result. Okay, so actually, this is the summary statistics of this data. It tells you the average value, the standard deviation, minimum value, maximum value, and the 3 percentiles of the data. So pay attention here, not all percentiles we print, only the 25th, 50, and 75 percentile of the data, okay? So here we have all the columns or all the features, and it tells us the average value of on-stream hours, okay? Actually, so this on-stream column is the flow rate. The second column is the downhole pressure. You already know this is downhole pressure and downhole temperature, okay? And then this is the annulus pressure, the choke size, wellhead pressure, wellhead temperature, the choke size. These are the produced oil volume, the gas volume, the produced water, and the water injection as well. So if you read more deeper into full field, actually there was a water injection happened in the field. So here you will see all of the summary statistics in our data. So this is quite important before we do the production data analysis. You have to know the average value of the data that you will inspect here. Okay. So these are the summary statistics of this data, and the next thing is we have to plot the data. Okay. Without plotting the data, we don't know how the data looks like. Okay. So first of all, you still remember how to use matplotlib to plot. So we exactly use the same thing here, plt.plot, okay? Because we want to plot the water volume and the produced water and the produced oil, okay? So we will plot this one. First is this one, and another one is for this one, okay? So the x-axis is our day production, and the y-axis is our water. First is our water volume, okay? And don't forget to use this plt.show, okay? So this is the plot, but we want to make it more cool, okay? So this is the second plot, the day production, and the oil, the borehole oil volume, okay? So we use color here. You can think any color, okay? Not just blue, black, and red. You can use any color, okay? So that makes your creativity to visualize any data. And if we want to control the size here, maybe 10, 6, okay? Maybe some more, maybe 17 or 15. That's enough, I think. Okay, so this is our data, okay? Maybe we want to show the grid and give the title production data, okay? And labels, the X label is the date, and the Y label is the because this is the cumulative production, okay? So capital Q instead of small q, because it tells the cumulative production, not the production rate. So this will be the standard barrel, okay? So you have to be careful with the units. If you are dealing with production, cumulative production, you define it as barrel. If you have a production rate, you have to define it as barrel per day, Okay. Okay, so this is our data. Okay. The next thing is another important thing in data analysis. In data analysis, we know about histogram. Okay, histogram reveals the distribution of our data. Okay, maybe some of you have already get statistics class. You know what is what is the meaning of Gaussian distribution or any other distributions in the data. So how to find the kind of distribution in our data, we use the histogram. Okay, so in Python, you can use still the matplotlib. Okay, here we haven't used the Seabourn and the missing no. In general, we already we just use the pandas, numpy, and matplotlib. Okay, and then for this we will produce the histogram of our data. We use plg.hist for what data? Okay, for example, any data that you want to see the histogram. For example, you want to see the production rate. The first column is our production rate. Okay, the on stream. Okay, so we can use this on stream. First, we want to see how the distribution is in our data. Okay. So we just wait for a second. Okay. Okay. So maybe we want to average downhole pressure. Okay. 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 That's okay. That's enough, I think. We will see the histogram or the distribution of our data. But here, if I see this histogram, I'm not too pleased with this histogram because I cannot see clearly the distribution in my data. I cannot tell whether this data is Gaussian or it is skewed to the right or skewed to the left, or it has certain leptocortic or any other terms you heard of from your statistics class. You can control the width of this bar, okay? So how to control this, the width of our bar here, or to control the distance between these individual bars? We use this bins equals any number you want, okay? So if we use 5 or 50 bins here, okay, you will see this distribution is more clearly seen here, okay? Maybe you can restrict the access you see here, okay? So one of the main observation you can see from this data, okay, there is an outlier in this, okay? This is an outlier because there are some values outside our distribution. Okay, this is our distribution, but this is the outlier. So using histogram, you can see the outlier of the data. Why you have to care about the outlier? Well, when you do machine learning or any other analysis, you have to care about the outliers. But sometimes outliers is important for our analysis. But you have to find the outliers in the data. Which data is outlier? Only not for the outliers. We can maybe from this to this. Okay. It will display only the histogram inside this distribution. Okay. So you can maybe plt.ylim from 0 to this, you will see clearly this is a bit looks like Gaussian. Okay, and if you maybe you want to control this is more maybe too narrow, you can control this. If you decrease the bin, the width of the bar will increase. Okay, so this one. Okay, and if you increase the bin, it will looks like more. Okay, more. It looks like better. Okay, and then we also know how to make a scatter plot between one variable and another variable. Okay, next week we will discuss about well log analysis, and another cool topic I think I want to discuss about natural fracture analysis, and we will relate it to hydraulic fracturing, and we will visualize the earthquake data. And one important thing in this data, we have to use scatter plot. Okay, so how to make a scatter plot? Okay, well, it is quite simple. You can use this plt.scatter. What variable you want to see, maybe stream HRS, and the another variable is the average downhole pressure. Okay, so this is the scatter plot of our data. Okay, so this the x-axis is the production rate and the y-axis is the downhole pressure. Maybe not the production rate, but the borehole or the oil production, bore oil volume. Okay, so you can see the scatter plot between two variables. But to make it more flexible in data analysis, we can create all scatter plots all at once. Okay, so if we know about scatter plot is a plot between one variable and another variable. So there are two variables in scatter plot, but in pair plot, you can produce more than two variables. Okay, maybe 5 variables, 10 variables. That depends on the number of your features. Okay, remember what is feature? Feature is our column. Okay, so we can make a scatter plot of all column names in our data. So that's why we use pair plot. Okay, now we will use another library. Okay, that is called the Seabourn. Okay, to make a pair plot, we use Seabourn library. So Seabourn is SNS. Okay, so SNS.pairplot. You can use this pair plot. And okay, so I will explain you first. I want to make a pair plot or scatter plots of certain columns. For example, I want to make a scatter plot of more than 2 variables, okay, of this production rate, and then this oil, the produced oil, and the analyst pressure, okay? So there are 3 variables I want to make a pair plot. So first of all, we define all the variables we want to visualize here, okay? So we make a list first, okay? Lists. First, this variable, this feature. The second feature is bore oil volume. The next feature is the average annulus press, okay? Press or pressure. I have to check it first. Annulus press without pressure. Okay, so annulus press, and then our input will be the data frame that contains only this data, okay? So we can use this list, and if we print the input, you will only see all the data from only these 3 variables. Okay, so in this 3 column, we will make a pair plot. Okay, so we use sms.pairplot and we pass the input. Okay, but if we run this function, you have to be patient because it takes quite a long time to produce the pair plot. Oh, that's really fast here. Actually, it depends on how many data that we have. For here we have how many observations here we have. So observations are the rows. Here we have this size of data. Okay, and it takes about 2 seconds or 3 seconds to produce this. For larger data, it takes more time to execute this this plot. Maybe you want to add another variable, for example, the average downhole temperature. Okay, average downhole temperature. So we wait for a bit because we add another data here. Okay. So what we can see here, this is the scatter plot exactly. This is the scatter plot, but here you can see all the data at once. Okay. How to read this scatter plots? This is the scatter plot between this variable, between this feature and this feature, and then for this one between this feature and this feature. What we usually get from pair plots, the first thing is correlation. Okay, maybe we cannot see clearly the correlation here. It should be like linear correlation or any other correlation, but here we cannot see any correlation. Okay, and the second thing is the the clustering. For example, maybe we have lots of wells, and I would like to see the clusters. Which one is clustered in this axis and in this axis? So basically, the two things you will get from pair plots is the first one correlation, and the second one is the clustering. Okay. So this is the scatter plot in our data. And you can see here okay, so basically we can see this the scatter data already produced the histogram here, and it shows also the histogram. Okay, and then the last 3 things that we will do today is how to visualize the missing values. Okay, so if you see back in our data, you will see that some data have missing values, missing data here. This, okay, so in this column, you will see some missing values. Okay, so this is the non-numerical values, or we call it as missing values. Here is also we see another missing values. Okay, but it is not too convenient to see the missing values using this table. We can visualize the missing values, which row contains missing values, using the missing no library. Okay, so it is quite simple. Dot matrix, and we pass the so okay, so for the DF. Our data frame that we want to inspect. Okay, so this, okay, so maybe it's not this what okay, so this is our data frame, not this one. Okay, so you can see here, okay, this is the plot of the missing values in our data. Okay, so rather than looking at this data or this table, if you run this, you will see using visualization exactly which row contains missing values. Okay, so the dark bars here are the data, but this one, the white ones, are the missing values. Okay, so we can describe here this feature: downhole pressure, downhole temperature, tubing annulus pressure, choke size, wellhead pressure, wellhead temperature. They have these missing values. Okay, and then this one. So you can read this at like this. This is from index 1 to index this one, and you will see you can describe which row has missing values. Okay. So if I ask all of you which features have complete data, okay, so you can see here this is the complete one, the NPD wellbore name. Okay, any missing values. And the second is the flow kind. This is the last feature we have. We don't have any missing values here. Okay, and you can ask yourself which feature has the most missing values using this visualization. Okay, and when we deal with missing values, we don't have to be worried, because there are lots of things we can do when we are dealing with missing values. The first thing, you can just delete all the rows which has missing values. Okay, that's the simplest method you can do. Okay, but if you have only certain data, not like thousands of data, you have only 100 data. Okay, if you delete the missing values, you will obtain only small portion of the data. So you won't like that because you lose most of your data. Okay. So the another method, when you are dealing with missing values, you can use interpolation. Okay. So now I want to show you how to interpolate for all of these missing values here. Okay. This one, I want to fill this missing values using interpolation. Okay, this is the missing values, this is the missing value. Okay, and then this one, this one, this one, this one, I want to fill all of this using interpolation. And we can use this using pandas. Okay, so we can interpolate this value using df equals df.interpolate. And there are lots of methods in interpolation. For example, the linear method, maybe you can see here clearly. The method is linear, and others, for example, cubic interpolation. Okay, but I want to show the simplest interpolation method, which is linear. So in this input, I choose the linear. Okay. And if we print, okay, so we interpolate this data first. Okay, so after running this function, you will get your data. This one will be interpolated, so you won't have any missing values. But wait, I have to. So my internet connection is unstable, so I have to visualize again the data after I use interpolation. Okay, so we can use this again. Wow, so we see here, right? So mostly all of the data have been, okay, the missing values have been filled with the interpolated values. Okay, only this one. Why? Because this interpolation cannot extrapolate. Quite important, because in the major portion of see that our missing values have already been filled. Okay, so instead of delaying these missing values, we can use interpolation. Another method is called the imputation. Okay, imputation is a method to replace the missing value with a certain number you want. For example, you want to fill this missing values with, for example, the average of the data. Okay, but I personally prefer using interpolation because it's quite more truthful, because we can interpolate this. Okay, we can interpolate this missing values. Okay, so we have already filled our data. Okay, so I think that's all for today. We have already covered at least the basics of data analysis in production data. So if we want to recap all things that we have already discussed today, okay. So here we know two more libraries, because last session we already know about NumPy, Pandas, and Matplotlib, and Seabourn is for visualizing the data. For example, you want to create a pair plot or a scatter plot or a histogram, we can use Seabourn. And this missing no library, this is for finding the missing values, okay, and visualize it, rather than looking at our table and search for the missing values, okay? And then we load our data using this function, okay? So this is our data, okay? So you have to remember what is called as feature and what is observation. So I have to is the row of our data. So these are the row, okay? And then observation is the, sorry. So the feature is the column of our data. These are the columns. And the observation are the row of our data, okay? And after we have already know about what is feature and what is observation, we have to convert this format, because we make this data in Excel. So we have to convert it first to Python using this function with this format.
Johannes,
So if you find this into Python format using this convention, other kinds of format, for example. Okay, sure. So here you have to remember every time when you have a data time format using this format, you can actually browse yourself in the internet, any other format, okay? And then with this code, we can print all of the features in our data. These are our column names. And also, we can print all of the well names in our data, okay? And then this one, we have already select from this data, only from this well, okay? We use mask to separate this well from the data frame. So we create a mask and then we apply on our data frame. So this is our new data that contains only this well. And then we describe the data, we produce the summary statistics, in summary statistics, you will see this average value, standard deviation, minimum, maximum, and the 3 percentiles, okay? And then we plot the data here. We use the matplotlib, okay? And then here we produce the histogram for our data. The purpose of this histogram, we can see the distribution of our data, and also we can identify the outlier of our data, okay? And then we have already known about how to make a scatter plot, okay? Scatter plot between two variables. But because we want to produce more than two variables, we use not scatter plot, but pair plot, okay? And for pair plot, we use the Seabourn library, okay? So we find this data, okay? So these are the variables, and these are variables. And also, we can visualize the missing values using the missing no library, okay? This is quite clear because we can see where's the location of the missing values. Without seeing the data, we can visualize it, okay? And then because we have already known that in our data we contain missing values, we have to deal with it, okay? Either we delete it or we interpolate it. But the first method is not preferable if you have only few data, okay? Because you will lose lots of portion of your data. So rather than deleting the data, we can use interpolation, okay? So we use the interpolation function from pandas, interpolate with a linear method. And after we interpolate the data, we will produce all the data. The missing values have already been filled with the data, okay? So that's all for today. This is the basics of the production data analysis. And I hope that you quite understand the basics, because you can even explore more data analysis technique to analyze production data, not only production data, but also reservoir engineering data, and lots of other data, well-log data, which next week we will discuss about how to analyze the natural fractures, okay? So we will visualize the well logs, and then we will visualize in 3D, okay? Okay, so I think that's all for today. I will share this notebook. I hope that the previous notebook, all the participants have already kept this notebook, and then I will share it to maybe to you, Alexandru. If the participants want to code with this notebook, I will share it to you after this tutorial. So thank you for your attention.
Thank you very much for this amazing session. Now I would like to read you some questions from our audience. So one of our students asks, what does mean outliers in histogram and what's their purpose?
Sorry, I cannot hear the question. Could you repeat the question?
Does it mean the outliers in the histogram and what's their purpose?
All the layers, sorry, all the layers in the histogram?
Yes, and what's their purpose?
Oh, okay. So
I can. What does outlier mean? Outlier, and
okay.
what is the purpose of that?
Yeah, I can see also the questions from the chat features also. So from Zakaria, thank you, Zakaria, for your question. What does mean outliers in histogram? Okay, I think you mean about the bars here, the bars in the histogram. Okay, so these bars here, what I can say. So if we look at this histogram, the first thing you will see here is the x-axis, okay? Because here I visualize the downhole pressure, so the x-axis is the downhole pressure, okay? So maybe I think this is in, the pressure unit is in bar, not in 150 bar to 400 bar here, okay? And this, the y-axis is the frequency of the data, okay? So if you see here the pressure at 250 bar. Okay, if you go here and then trace to the y-axis, you will know at this pressure how frequent the data is inside our data. So this is the frequency of the data. So how frequent the data is in our data. So you can see here, this is the most frequent value in our data. So from this histogram, we can know that the most frequent pressure we find is this pressure, 250 psia. Okay, so you can find the frequency for all other bars here for 200 and 350. So how many frequency? Okay, so histogram tells you how frequent the data is in our data. Okay, so that's quite simple to understand, because this is really important in data analysis. We have to produce the histogram to better understand our data. Okay.
Okay, thank you very much. Another question is it practical to combine the curve fitting with pair plot features to identify the right correlations that fits our data?
That's a good question, because in Seabourn, okay, actually we can draw the regression line in our data. Okay, we don't have to use the curve fitting function that we have already discussed last session. In Seabourn, it has the built-in function. If you search in Seabourn documentation, pair plot documentation, maybe I will show you here Seabourn pair plot here. You can see the regression line on the data. So this is the documentation. You can go to this website. Okay, I think it looks like they doesn't have the regression line here. Okay, so visualizing regression models, maybe I just go straight to the image. So for example, this one, okay. So this is generated using Seaborn pair plot. And if you browse more into this website, you will see that to produce this curve fitting line, you will have to provide another input. Okay, so for example, you can see another input for producing this curve fitting line. That is possible, and you don't have to make your own curve fitting function using SciPy, as we have already discussed last week. We can provide another function to produce the line. Yeah.
Thank you so much. Another question is, how can I get the data to practice on my own?
Yeah, actually, that's a good question, because as a student myself, when I was still in the university, I was asking to myself where to find a data for my practice, because at the time I only know that data is really confidential. You have to get the permission first to a company, but later on I find that actually there are lots of public data in the website. Okay, one of the data here is from the fall field. Okay, so in the first slide I show you this website. Okay, so if you go to this website, you will see that this fall field data, you can download all the data. Okay, so maybe you can go to the full data set, you will be redirected to a certain storage, and you can access the data for free for your practice. So you can practice anytime with any data. Okay, there are lots of other data. For example, you like geothermal. Okay, there is a certain repository here that is called the Geothermal Data Repository from the U.S. Department of Energy. So maybe GDR OpenEI. This is another data repository for geothermal. Okay, you can find lots of the data here. For example, here, this one you can see all the data, seismic data or production data, and lots of data. Okay, actually, I have compiled some list of open public data sets. I often post it in LinkedIn about certain public data sets. So I think there are lots of data, so you don't have to be worried how to practice with a certain real field data set, because there are quite lots of field data set on the website.
Okay, thank you very much. The last question will be how to export a table of data from Collab website.
Oh, I think you may refer to how to import a data from maybe from your local computer or something. Is that right? Like we access the data from other source of data, right? Is that what we mean? Yeah, I think yeah, that's a quite important thing we have to know. Here today we just access to certain website, but actually we can also upload our own data. Okay, maybe I will show you here. You can go to this panel, and then so this button, you can upload your own data. For example, I have my own data, maybe this one of okay, so I have, okay, so maybe here, this is my data. This one, maybe I want to text document, or okay, so this is a text file. Okay, so you can upload your data here and wait until it's uploaded. Okay, and then once it is uploaded, you can use this exactly the same syntax. So you have the by the path to your data. Okay, so you can see here content, your name file .txt, and then you will load the txt file using numpy. Okay, so that's all you can do. Google Colab. I suggest that everyone here, there are lots of tutorials in the YouTube how to do with Google Colab and how to run codes in Google Colab, because actually we can do certainly all things in Google Colab. We can upload, we can export, we can import, we can stream the data, or we can also synchronize the data to our Google Drive. If we store the data in our Google Drive, we can directly access the Google Drive to our Google Colab. So I think that's an important thing. Yeah, I think that's that answer your question.
Okay, so this is all for today. Thank you very much for this insightful presentation and for answering our questions.
Yeah, thank you very much. Thank you very much, everyone, for attending this presentation. So I'll see you next week for another interesting topic, which is the natural fracture analysis. So I hope you enjoy this session. So I'll see you next week. Yeah.
Okay. Now I would like to remind you all to not forget to submit the quizzes. And on behalf of BioPetro, I wish you a wonderful day. See you next time.